So now let's move on to operators in C++. So you might have come across operators in mathematics as well, like plus, minus, multiplication or division. So what is the use of operators? Operators are basically symbols or a combination of symbols that are used to perform some particular functions like addition or subtraction on the operands. Now operands is basically a term. Let's see what is that. So terminology in C++, in operators. Operands. So operands are basically those things on which we are using operators to perform that function. So for example, if we have a plus b, now plus is obviously our operator and this a and this b will be our operands because we are using the plus operator on these two operands. Now, precedence of operators. Now, in maths also you might have come across, suppose an expression 2 plus 3 divided by 4 multiplied by 6 plus 7, etc. So basically, if in a single expression a lot of operators are used, we should have a plan according to which we know which operator will be evaluated first. So just like in maths we have bod mass, it gives us the priority in which operator will be evaluated first. The same is in operators in C++. So basically the precedence of operators tells us which operator's priority is first. I'll show you the table at the end once we are familiar with all the operators. And now associativity of operators. So basically, if we have to do a simple expression like 2 plus 3, so we can just visualize it as we have first 2 and then plus and then 3. So basically the associativity of the addition is left to right because we are first evaluating 2 and then we are adding 3 into it. Now classification of operators based on their functionality. So different operators have different functions, so based on that we classify the operators. So the first one is arithmetic operators. Now these operators obviously you will be familiar in mathematics. So there is addition, subtraction, multiplication, division, and modulus and increment and decrement are the two new which you might be facing. So let's move on to addition. So addition is simple. It is used with two operands, like I said, a plus b or 2 plus 3. So with the plus operator, there will be two operands. And the two operands can be variables or literals or a combination of both. So like if we have a variable which has value 2, we can say C out 2 plus a, so we will get 4 because a was storing 2. So or we can say C out 2 plus 2, or we can say C out a plus b, both being variables having some values, and etc. So it returns the sum of the two operands. Now subtraction. Now subtraction is just the same, two operands, and they can be variables or literals, and it returns the difference of the two operands. Next, multiplication. Now multiplication we use the star symbol. So this is a multiplication operator, two operands, and it returns the product of the two operands. Now next we have division. Now in division it's just the same, two operands, and it returns the quotient of the two operands. Suppose we have 10 divided by 2, we get it returns the value 5. Now next would be modulus. Now this would be a new one. Basically, if we have suppose the division operator 5 divided by 10 divided by 5, we'll get 2. So in that we are getting the quotient basically. But in this, suppose we write 10 modulus 2. So we are going to get 0 because this returns the remainder if we are performing integer division. So like suppose I have to do So suppose I have to do 10 modulus 4. Suppose I have to do this. So basically I'll just do this thing like we do in maths. So this will be 2, this will be 8, and we'll get 2. So now as the remainder is 2, this will give us the output as 2. because this operator, modulus operator, will give us the remainder. So yeah, that was about the modulus operator. So now we have the increment operator. So now the increment operator, as it is written, it is used to increment the value of variables by 1. Now as you can see here, it is used only with one operand. So like you cannot say a plus plus b, because that won't make sense. We have to increment by 1 the value of this variable. So, and yeah, it is only used with variable and it cannot be used with the literal. Like if a is stored as 2, if we say a plus plus, then the value of a will get incremented and in the memory, and it will be now stored as 3. So now there are two types, post increment and pre increment. Let us see post increment. So yeah, now as the name suggests, post increment. So basically post increment says that if in an expression we come across a plus plus, so the increment would be done after it is evaluated. So like suppose I have an expression such as a plus plus. So in this particular statement, the value of a will be used as a only, and from the next expression onwards, the value of a would be incremented and this value will be used further. So yeah, now the second one is the pre-increment. So in pre-increment, you can see that it gets incremented before the value of a is evaluated or if it is used. So similarly, yeah, if this is a pre-increment, the value used in that particular expression would be used as the incremental value. So yeah, now we'll see some execution of the codes. Yeah, so let's see, this is the code. So basically, first we have declared a variable a, which has the value 6, and we have declared an empty variable b. So now we are performing b is equal to a plus plus. So basically, we are assigning a plus plus to b. Now basically, how this works is that, so basically we have this variable a with this memory space, and we have b with this memory space. So basically now a is having 6 and b is having some value. So now when this is evaluated, b is equal to a plus plus. So as I said, this is a post increment. So what happens in this is that the value of a, the original value of a, is evaluated first and assigned to this variable. So value of a was 6. So b will be stored in this 6 will be stored in b. And then, since the next expression onwards, a will be incremented. So now your 7 will be stored. So now our expected output should be b, which has the value 6 now, and a, which now has the value 8. And because of postfix, we won't be getting 7 in b. Now let's see the output. Yeah, so now the value of b is 6 and value of a they're getting as 7, which was I expected. So now let us look at pre-increment. So now as you can see, this is exactly the same program. A has value 6, b is an empty variable, and now we are doing pre-increment of a to b. So now so basically what we are doing is we are assigning plus plus a to b. Now as I said, in pre-increment, what happens is that the value of a gets incremented first in this expression itself. So the value of a was 6. So first it gets incremented, it becomes, let me make this again. So value of a was 6, b was empty right now. So now first it will get incremented, it will become 7. Then the incremented value will be assigned to a. So this will become, this will become 7. Yeah. So now if we output both these, we are expecting to get 7 in both. So now let us see the output here. So see, if their output B is also A, B is also 7, and A is also 7. So yeah, now let's get back to the PPT. Yeah, next slide. Yeah, so now we have exactly the same things for decrement. There is a post decrement and a pre-decrement. So now it is exactly the same. It is used with one operand, and the operand cannot be a literal. It can only be a variable, and etc. Let's go to the next slide. Yeah, so post decrement will be exactly the same, and then pre-decrement will be exactly the same thing. Just like the increment and just like the pre-increment and post-increment. Yeah. So now the second type is the relational operators. So now we have also used this in mathematics, like we can say 7 is greater than 3 or 4 is less than 5, etc. So basically this operator again uses two operands because it has to compare the two operands, and it returns 1 or 0 depending if the condition is true or not. Like if we say 6 is greater than 7, it is false, so it will return 0. So just like that. So first is greater than, it uses two operands, and it can be variables or literals or a combination of both, and it will return 1 if first operator is greater than the second, and 0 if it is not greater than the second. So basically if the condition is true or not, so that we can visualize it easily. After this is less than, so less than will be just like this. If the first value is lesser than the second, then it will return true, so it will return 1, and similarly in the second case it will return 0. Then greater than or equal to. So greater than or equal to is just like greater than. Obviously we use greater than and equal to in maths as well. So in this it will check if the first number is greater than the second or if they are equal. If either of the conditions satisfy, it will give 1 as output, and we will come across this or and as well in the upcoming operators. So after this is less than or equal to, which is the same logic, and after this we have equal to operator. So basically you will notice here that we are using two equal to symbols, but this symbol is referred to as equal to. We don't call it double equal to in C++. So yeah, it uses two operands because it has to compare the two operands. If both the operands are equal, then the return value will be 1. If they are unequal, then it will be returned 0. Yeah. So after this not equal to, again it is just the opposite of the equal to operator. If they are same, it will return false, which is 0. If they are not same, it will return 1. Now, so after this we come to logical operators. So logical operators, basically logical operators are used to perform logical expressions which are and, or, and not. So let's go to the next slide. Yeah, so logical and. So basically logical and can be explained as an example. Like suppose if I want to order ice cream, I'll say I need chocolate and I need choco chips. I'm using and between those two conditions. So if somebody brings me an ice cream and it does not have either of one of them, so that will make me angry because both of my conditions are not satisfied. So and is just like that. This, what we have is called a truth table. So basically I am using all the combination of x and y, 0, 0, 0, 1, 1, 0, and 1, 1. So if either of them is 0, which means either of my conditions is not satisfied, we'll get the output as 0. But it will give one output only if both my conditions are satisfied or both of these conditions are true. So this was about and now we have logical OR. So logical OR is just like I'm ordering ice cream and I want give me either chocolate or give me either choco chips. So basically, if there is only either he brings me chocolate, either he brings me choco chips, I'll be satisfied. But I won't be satisfied if there are none of them. So just like this, if there are 0 and 0, then obviously the output will be 0. If either one of them is 1, the output will be 1. Also, you can also visualize this as maths addition. Basically, if both are 0, both terms are 0, 0 plus 0 will always be 0. If either one of them is not equal to 0, then we will get true output. And in AND also, if anything multiplied by 0 is always 0. If both of them are not 0, both of them are 1, only then we will get the output as 1. So yeah, logical NOT. Now logical NOT, as you saw in the previous one, the logical AND and the logical OR, it has to like take both the operands, only then it will give an output. But in this one it needs only one because it basically takes one's complement. Okay, so it takes a complement. So basically if I have 0 it will give me 1, if I have 1 it will give me 0. So it's that easy. So now next is assignment operators. So assignment operators are basically used to assign a value to a variable. So basically we have some assignment. One is the normal assignment, and then we have addition, subtraction assignment, multiplication assignment, division, remainder assignment. So let's see what is the normal assignment. So yeah, so here basically it's used to assign. So let me just show this. So basically if I'm assigning, if I need to assign the value 3 to a variable a, basically first this will be evaluated, this is 3, and then it will be assigned to this variable. So basically you can see that the operation is going from right to left. So remember we talked about associativity. So basically assignment operator is associativity right to left, because this thing is going from right of the operator, and then it is going to the left of the operator. So that is about the assignment operator. And then addition assignment. So now addition assignment is, it's basically compound assignment. So what is the use of this? Basically suppose if I have a variable say a, and it already has some value 5, and I want to add suppose 10 to the variable. So I can, I want to add 10 to the variable, and I want to store the new value again in a only. So basically I am adding the value and I am assigning it to the same variable. So for that we can use a equal to a plus 5. Now like I said, first the right thing of the equal to gets evaluated. So this will get evaluated and then it will be stored to this. So a is 5. So 5 plus 5 will get 10, and then it will be stored again in this. So now we are repeating this thing. So we can alternatively write this as a plus equal to 5. So basically what this will, this statement and this statement is exactly same. It is the same function. This is just writing, this efficient way of writing this. So like I mentioned it here also. This is exactly same. So yeah, that was addition assignment. Now we have subtraction assignment. Subtraction assignment is just the same. Like if we want to subtract some value and store it in the same variable, we can use this a minus equal to 10. Similarly, we will have multiplication assignment, and it is just the same. Like I said, if you want to multiply a value to the value in the variable and we to store the same thing in that variable only, we use multiplication assignment. Then we will have division assignment, and after this we will have modulus assignment, remainder assignment. Yeah. So basically same thing. If we have 5 in a variable and if we want to get the remainder of 5 divided by some number, say 2, and we need to store it in that variable only, we will use this. So yeah. After this, bitwise operators. Yeah. So basically we saw that the operators, the logical operators, we saw. So basically logical operators work on 2 numbers. So here bitwise operators also work on 2 numbers, but basically they convert the number into binary form, and then it performs the logical operators like AND, OR, XNOR and NOT. It works on the numbers bit by bit. So yeah, let's go to bitwise AND. So in bitwise AND, it is said it converts the value of both the operands into binary form and then performs logical AND bit by bit. So yeah, so let me give an example. So suppose I have a number, let's say 6, and I have 2. So 6 in binary is written as 110, and 2 in binary is written as 10. I'll add a 0 here. Okay. So now I will perform the AND operation. Okay. So basically 0 and 0 will give me 0. 1 and 1 will give me 1. 1 and 0 will give me 0. So this is the output, and you can see that this is same as 2. So in this case we are getting 2. It is nothing like if 2 is written here, we'll get 2. It isn't like that. So we'll get 2 in this case. So that was about 2. It converts this number into binary, this number into binary. Then it performs AND bit by bit, and then we get this as the result. And then this number was 2 in binary, so the result is this. So we get this number. So that was bitwise AND, or bitwise OR again. So if we want to see bitwise OR, again the same thing I'll take. So like if I have 6 and I have 2, 1, 1, 0 in binary and 0, 1, 0 in binary. So now 0 or 0 will give me 0, 1 or 1 will give me 1, 1 or 0 will give me 1. So now you can see in this case we're getting, like that was 2 and this was 6. It has nothing to do with the similarity of these. So we'll get here 6. So again bitwise it checks for OR, the logical OR, and then we get as a output. So that was logical OR. Now bitwise exclusive OR or XOR. So basically what this is about is that the explanation is here of the OR. There is a logical OR just like we had AND and OR. So basically if the operands are same, it returns 0. If they are different, it returns 1. So basically, for example, if again I take 6 and 2, if it is 1, 1, 0 and 0, 1, 0. So basically if, so I need to perform exclusive OR. So basically if they are same, so 0 and 0 are same, so it will return 1. 1 and 1 are same, it will return 1. And 1 and 0 are different, so if it is, oh my god. If they are same, it returns 0. So I'll get 0, I'll get 0, and I'll get 0, and I'll get 1 here. So basically this would be 4. So so we get 4 here. So if we use the bitwise XOR on these two numbers, this will be our output, because bitwise we are calculating XOR this. So that was about bitwise XOR. Now we have bitwise NOT. So we saw what is NOT. NOT is very easy. Basically if we have, and again because it is NOT, it will work only on one operand. So if we have 6 here, 6 is 1, 1, 0. Okay, so we have to take bitwise NOT, bit by bit NOT. So it will be 0, 0 and 1. Okay, so this I think this is 1. So we'll get the output as 1. But the problem here is that this is a note here. Integer data types usually uses 32 bits to store numbers, and it has a large number of leading zeros. Like suppose if I have this, so if I want to make it to 32 bits, I'll have to add 0, 0, 0. So now if I take bit by bit complement, in signed binary there is a method of turning signs like positive and negative integers. So basically, if the first bit of a signed binary is 1, the numbers get turned into negative numbers. Now that is a long procedure, we're not going into that. So basically, I've just told you to, like, if you try it out by yourself, usually you will get the bitwise NOT complement of an integer. Many times it returns negative numbers. So that was about that. Now we have a right shift operator. So again, if you use right shift operator on a number, it will convert it to binary. So suppose I have 6. So 6 is 1, 1, 0. And if I perform this right shift operator on 6, so so if I say 6 and I have to specify another operand 1. So basically what this expression means is that the binary form of this has to be right shifted by 1. So this right shift basically means that everything here will move to right. So this cannot move to right because obviously it is on the right side of it. So this thing gets truncated, and what we add here, this new space will be filled by a 0. So now this, I think this will become 3. So if we do 6 right shift 1, we will get output as 3. So similarly, there is a left shift operator. Left shift, everything will move to left, and whatever for 6 we will have 1, 1, 0, and if we move everything to right, we get 1, 0, 0, because we truncated this and we added a trailing 0. So basically we get this, and this is 4. So that was that. So now miscellaneous operators. Let's see the first one, which is comma. So comma is basically it requires 2 operands, and it is used to form multiple operations in a single statement. So like so basically, usually we declare variables, like suppose I say int A equal to 4, and I say B, and I say C, okay, and then I close the statement. So basically what comma does is basically, suppose if we take this one, first this expression, because comma is between these two. So this will get, this will get evaluated, and then it will move to here, and then this will get evaluated. So basically it will just, it's used to separate these. Yeah, now next is size of operator. So now basically size of operator, now we have seen this, we put something inside the parenthesis of this size of. So basically if I write size of A, so it will return how much memory this A variable is taking. So yeah, that's that. So if it is an integer, it will return how much memory allocation that is taking, and etc. Yeah, so next is condition operator. Now this is very important. So basically condition operator uses 3 operands. So basically the syntax is like this. So there is a question mark. So before the question mark there is an expression. Now based on that expression, if it is true, it will jump to the second operand. If it is false, it will jump to the third operand. So basically usually in A there is a condition. Based on the condition is true, basically it evaluates to 1, it will jump to second operand, or else it will go to third operand. So yeah, let's see the code for this code execution for this one. So yeah, now let's see the working of this one. So basically here we have a variable A which we have assigned the value 2, B assigned the value 6, and C is an empty variable here. So basically yeah, we are performing this. We are storing in C the value. We are using this conditional operator. So basically we will see this if A is greater than B. Now if this condition will give us true, it can give us true value or false value because we are using a relational operator. So A greater than B, A is obviously not greater than B, 2 is less than 6, so this will give us false. So now, as I said, if it is false, it will jump to the third operand. So the second operand, this is the third operand. So it will jump here. So now this thing is equivalent of C equal to B. So now B will get assigned to C, and 6, so our output, we are outputting the C value of C. So basically our output should be here 6. Let us see the output. So we're getting the output as 6. So yeah, let's go back to the PPT. So yeah, that was conditional operators. So yeah, now I'm talking about precedence and associativity of the operators. So basically the first one will have the highest value. So if in one expression we are given a lot of operators, just like word mass, the first, this will be evaluated, this one, and then post decrement, then in this order. So let us see the next, the continuation of this table. So yeah, you can just see this one for your reference. The next slide. Yeah. So as you can see, the comma is evaluated in the last because comma is just used for separation, like I told. Yeah. So next. Now classification of operators we can also do on the basis of number of operands required. So like there was increment operator, it uses only one variable, it presses the value is 1. Or A plus B, it uses 2 operands, and the conditional operator uses 3 operands. So yeah. So unary operators, it requires only 1 operand, you can see, and this one is plus 1. So basically plus 1 is basically for denoting positive or negative integers. So this is negation 2, and this is increment, decrement, not, etc. Next will be binary operators. It uses 2 operands. Each one of them uses 2 operands. Next one is the ternary operator. We just saw this one, conditional operators. Yeah, so that was it. That was operators in C++.